This is GDC 2003. This is my talk on building object systems, features, trade-offs, and pitfalls. Okay, who am I? My name is Alex Duran. I'm a programmer at Ion Storm in Austin working on Deus Ex 2 and Thief 3. I wrote the object system for our games. I'm doing some other stuff since then. This talk, I'm going to first talk about the purpose of the talk and the scope of the talk. There's some things I'm not going to cover, and I want to make this clear from the beginning. Then, I expect most of us to find a lot of these terms in the same way, but I want to make sure we define them in the same way, so I'm going to just go over a couple of terms and get us on the same page. Then I'm going to briefly go over static hierarchies, kind of describe what they mean and why we're not going to talk about them. And then go on to the bulk of the talk, which is about component-based systems or dynamic hierarchies and the kinds of things you can do with them. And then there'll be a summary at the end. Okay, so when I was writing the object system for Deus Ex 2 and Thief 3, I had a lot of experience. I worked on Thief 2, not writing the object system, but definitely using the object system that Marc LeBlanc wrote. And I had an insight into how that worked from a client's perspective, programmer or designer. And I also saw what Unreal's object system was, and we were licensing it. And so I said, okay, well, we need to make a system, and I want to address the problems I've seen before, try to fix them and improve upon them. Despite all that information, I still made a bunch of mistakes. And what I'm trying to do here is let people know about what the options are when you're building these systems, what the potential consequences are, good or bad, so that you can better plan for your particular game. Right? This is not a catch-all solution. Each game has different goals and wants different systems, and I'm hoping to impart what consequences certain decisions will have upon your game. My experience is basically all in single-player games, certainly as far as any technology goes, and fairly large development teams. That's the entire development team, designers, artists, programmers, audio guys. A couple things I'm not familiar with. I'm not familiar with network communication for object systems. I'm not really familiar with persistent worlds, massively multiplayer games. There's a little bit of information about that, but not much. And if there are differences that are applicable to really small teams, I'm not really going into those. And one other thing is I'm not going to have much time to talk about references between objects. So I'm somewhat familiar, but the talk only had so much time. I'm just going to define a couple of terms to make sure we're all on the same page. What do I mean by an object system? An object system is kind of a database. It's the code that stores objects and attributes about them. It's a system, clients are other game systems that programmers write and designers. It answers questions like, hey, how many hit points does this medbot have? And it can do things like when I shoot the medbot, I can say I want to remove 5 hit points from it, and it'll store that change and keep updating that information. What's a hierarchy? A hierarchy is kind of a tree of archetypes or templates. Things inherit from other things. They extend their functionality. Here's a sample of some of the hierarchy from Deus Ex 2. We can see we have the bot section of our hierarchy. We've got a hunter-seeker bot, a med bot, a military bot, and they all have a common parent. That parent is the bot archetype. And the bot and some announcers and some other things you can't see off the bottom of the screen, they're all AIs. And then they continue to go up from there. And sometimes it's a single inheritance, like DX2 AI pawn has a parent AI pawn which has no other children. It does for Thief and branches there, but in our system it doesn't. Okay, what is a component or a property? Scott Biles' talk last year used the word components. I'm going to try to use the word components. Our system calls them properties, but they're basically the same thing. Component just kind of implies a larger piece, but essentially the same. Here we're looking at the main health component. It's on AIs, and in this case it's on a medbot. It's got how many hit points he's currently got, how many he can have max, and what location it's used for our damage system. What do I mean by an archetype or an instance? An archetype is sort of the canonical medbot. It's a template for a medbot, so when I take that and I create one in the world, I'm creating an instance medbot from that template. In this case, we're looking at a cell phone, a medbot instance, and its parent is the medbot archetype, and then we go up through the hierarchy there. So our hierarchy will also include instances. Okay, what's a designer? A designer is someone who edits data on the archetypes or the instances. A designer, when he makes his changes do not cause code to get recompiled. And the designer is not a programmer. I mean, he may be a programmer, but for purposes of what we're talking about, he does not know how the system works underneath, right? He only sees the outside result. Okay, that's a couple of definition of terms. We'll talk briefly about static hierarchies now. A static hierarchy is the standard C++ model of inheritance. You know, this inherits directly from that. We share member variables. You know, we override virtual functions. But it's locked in code, right? It's not data. You don't change it without recompiling or any of that stuff. Components are required, right? When you override something, you don't lose any member variables. You've got all the member variables of the parent. You've got all the functionality of the parent. And so you grow this hierarchy, and memory and complexity start to become, you know, are always issues. And so if you decide, wow, this branch has this feature, but I'd like this other branch to have the same feature, you can't do that without bringing up member variables up to whatever common ancestor they have. But now every other branch is also paying the memory for those member variables and the extra complexity of code. So it doesn't allow you to fix unanticipated design changes. On the other hand, there's no extraneous data generally. You've carefully limited where the data is, and it's a lot faster, and you can, you know, do it at compile time. As an example of what can go wrong, there was a game, Ultima Underworld. I'm sure many have played. It's a first-person RPG, fairly complex, and they made a design decision early on when they're outlining things that the ability to have conversations was an AI thing. It only went on AI objects. And the problem arose later that they needed you to have a conversation with a door. But doors were not AI objects. They're a separate thing. And they didn't want to push all the relevant data for conversations up to the root because now everybody's paying for that memory. So they had to do a hack where when you click on the door to interact with it, they create an invisible worm and you have a conversation with the worm. And it goes away at the end. And they got around the problem, but it would really be really nice if they could have just had a system that allowed them to make these changes without extra penalties. Sometimes it's a great thing. Halo 1, fairly well understood design, clearly a successful game. They had a fairly simple hierarchy. You know, you kind of understand what a first-person shooter does. So you can take a pretty good guess as to what the layout wants to be. And there's still a few problems, like some archetypes maybe should have been split up more. But again, you still aren't hitting the problem of trying to end up pushing data later because you're missing functionality, which is a little bit too much functionality in some places. And of course, when you go into Halo 2, you really understand the design, right? We've done this game before. We know exactly what the design problems we're going to encounter. We can make a static hierarchy. It's going to run really fast. Everything is the right size it should be. And we get all these advantages because we aren't going to have to hit design surprises in our hierarchy. Dynamic hierarchies are mainly there to deal with those kinds of design surprises. They're determined entirely by data. Data determines the organization of the hierarchy. It determines the kinds and value of data on archetypes, and it determines the values of data and the kinds of data on instances. And it determines whether or not I have data about conversations, not just what it is. And you can do kind of hybrids where the top of your hierarchy is static. We do this for Deus Ex 2, where, you know, we separate particle emitters and AIs and everything else in kind of 3 different classifications. And we just said, okay, look, you know, we're not going to have things normally revealed emit particles. If we want to do that, we have to attach an object. But we're okay with that. And then below that, we have a lot of flexible functionality. Okay, so that's kind of what the basic getting us up to the same page. If you need more information on that, Scott Biles gave an excellent talk last year at GDC 2002. Doug Church recently gave a speech on object system design. I recommend these as alternate references. Okay, and here we're going to have a little bit, again, a definition of a term, but it's more applicable, and I suspect fewer people are familiar with it. or what I mean by it at least. So what do I mean by inheritance? Well, one of the key components of dynamic hierarchies is that components are optional, so objects don't have to have them. Now, if I've got an undamaged medbot in the world, and the archetypical medbot has values for how much health it's got, why does that medbot need to store health? Well, it doesn't when it's just been placed, right? It's fully healed. I might as well just say, my system's going to handle it, so if I ask the medbot for the health, it's going to say, I don't have a value, ask my parent, and we're going to get back with 25 hit points. Obviously, you sometimes do need to store things. If the medbot takes damage, you have to store values right there because it now is different from the archetype. We don't want to damage all medbots when I damage a single one. As an example here, we're looking at an instance of a light, and we're looking at 4 components in the light archetype and 4 components for the light instance. The 2 that are grayed out are not on the instance. I'm getting their values by saying, I don't have it, ask my archetype. The other 2 are overridden and specifically on the instance. Now it's important to note that you don't override just differences, like the not spawnable flag. You also override similarities if you want to make sure it's locked. If someone decided later to change all lights to be that they could be, to change the be not movable render flag, the fact that I've got this one on this instance, it won't update because I know how I want this instance to behave, and I don't care about the archetypal one in this case. I want this one to behave this way. So you override both in similarities when you want to keep the value and differences to make that distinction. What are the benefits of inheritance? Well, inheritance removes the problem of storing redundant data. This does 2 things. One, it saves memory. Right? You don't need data in 2 places. You should put it in one. It cleans up your memory usage. The other thing it does, and often more important, is that when you have redundant data, you have data in 2 places, and designers are going to be changing that, and eventually one of those 2 places is going to be wrong. And then you're going to get bugs, and you're not going to know, and it's going to be hard pain to track down, and you're not going to know which is the correct version. So we're trying to use this to eliminate redundant data so that data is always in sync. There are costs associated with inheritance. If an object doesn't have a component, I've got to ask its parent. I mean, that's the point of inheritance. But if the parent doesn't have it, and its parent doesn't have it, I just keep going up. It's not uncommon to have archetypes or instances that have 5 parents. So, in fact, when I ask an instance in Deus Ex 2, and it doesn't have a value right there, on average, I do about 3.6 more queries after that. There are strategies to deal with these problems, and that's I'm going to cover when I go on to the next bit of inheritance, kind of at the end of the talk. I just wanted to get this definition done with some explanation of the problems. One quick example of a failed query is that I have a stool, it doesn't have health, it's indestructible, right? And so I ask it for its health and its parent, and then the parent set dressing interior, the parent DX2 actor, and the parent actor, and I've done, as you can see, 6 queries for a failure. Right? I'm talking about component-centric systems versus object-centric systems. I'm going to discuss what I mean and why you might pick one or the other. Okay, what is an object-centric system? Object-centric is the conceptual way you think of object systems, right? You've got objects, they've got data associated with them. That's how it is. Like a medbot has hit points. The hit points belong to that medbot, and this medbot's hit points belong to it. It's also the way, because it's the intuitive way and the conceptual way you think about it, it's the way you pretty much always want to present it to designers. Designers want to look at this object and say, what values are associated with it? So even if you were doing a system different from object-centric, you'd present the data as in an object-centric fashion. Well, if that's the standard, intuitive way, well, what's component-centric? Well, in a component-centric system, objects are just identifiers. They don't have any data associated with them. They're identical. You might as well just have, a giant array with a little flag saying whether or not this ID is used. All the data is stored in components. They store identifier data pairs. The health component stores ID 5, 25 hit points. The behavior of an object is determined entirely by what components store what data associated with that ID. Now, as I said, you want to present data to designers in an object-centric fashion. So this is an internal thing only. You're still going to present data to designers in an object-centric fashion. Thief 1 and Thief 2 use this. Quick example. You can see that we have a couple of components. In fact, even the parent of an archetype is not stored on that ID, right? They're just IDs. And we can look and say, well, ID 3, it's according to the name component, ID 3 is a guard number 2, and the hit points component stores 10 hit points for it. And ID 3's parent is ID 1, which is the guard archetype. And we can, by doing a bunch of queries and saying, okay, what's, parent component, what parent is this ID, name component, what name is this ID, we can eventually find out, oh, okay, this must be a wounded guard, ID 3, because it's got fewer hit points. But as you can see, all the data is stored by components. The objects are just numbers. Okay, well, why would you pick one or the other? Well, you'd pick object-centric because it's intuitive. It's the way you're going to present it to designers. It's the way that makes sense to people to use the system. It's quite possibly the way you want to present it to a lot of client programmers. And it's easy to write because it's intuitive. It's not just easy, but in cases where I really want to bring objects in whole cloth or take objects out as a single unit, it makes a lot of sense. If I'm doing streaming, I want to take the objects out behind me and bring objects in ahead, and in an object-centric system, they know how to bring their data in. They come in all together or leave all together. They can also have associated code. If you're doing a sort of static dynamic hybrid hierarchy system, you can associate some code with them because they're not just IDs. And finally, you can scope components and say, the components for emitting particles are not going to be on anything but the emitter. And if you desire this behavior in a component-centric system, about the only way you can achieve it is by having some components exclude other components. And you say that if I have the AI component, I cannot have the particle-emitting component. Okay, well, why would you be component-centric? Well, the main thing is it's efficient. Right? Because each component stores its own data, it can optimize for the way the data is stored and the way it's accessed. Right? We have a component called hack strength, which determines how hard it is to hack a keypad or to unlock a door. And it's not on very many objects. Versus mass, which is on all sorts of objects everywhere. So for hack strength, you can do some structure that's like a small little dynamic array or maybe a linked list that works fairly well for small amounts of data, but doesn't work well for large amounts of data. For mass, possibly you want an array that's fixed to the entire number of objects I can have, because I know it's roughly going to be that size. I don't have to do fragmentation or extra allocations. It's also random access versus iterated. Right? When I wanted to hit something for damage, right now I need to say how many hit points are stored for that ID. I need to get that answer right away. When I'm doing physics, when I'm running a physics simulation, I may just want to iterate over every object, every ID in the physics component, and run the simulation on its data. And so I can store things completely differently there. But also, in sort of the way that object-centric allows you to have code, because component-centric doesn't allow you to have code, it helps enforce the data-driven aspect of the game. Right? The game is forced to be data-driven. That's the overview of component-centric versus object-centric systems. And component-centric can be a little bit confusing. No one I've ever seen explain it to, including myself, really got it completely on the first explanation. I hope I provided enough information. But it is confusing to think about. There's a reason that object-centric is good, because it's intuitive. Okay, now I'm going to talk about simple versus complex components. A complex component is kind of an aggregate or bundled component. A simple component is a single value, like hit points, mass, elasticity, friction are all simple components. But if I bundle elasticity, mass, and friction together, I get the physics component plus some other values in there. I may bundle hit points with regeneration rate and some other things to form a damage model. So simple components have some pros and cons. They're lightweight, right? I'm just adding one value to an object, one value to an instance, one value to an archetype. It's very easy to do inheritance. I never want to override just the tens digit of hit points. I want to override the entire thing or not at all. On the other hand, they've got a lot more allocations. Because components are optional, we store them, for instance, with pointers to data. And so if I'm storing hit points, I'm also storing a pointer to it. In fact, we spend more than 50% of our memory that's used in our object system on tracking. Our components tend to be fairly small. You also have to be careful not to split up functionality too much. I'm going to get into an example in a couple of slides about our inventory components. Okay, well, complex components also have some pros and cons. On the good side, they keep relevant data together, right? I'm a designer. I add the physics component. I see all the data I need to edit. I can see, okay, I can think about mass, I can think about friction, I can think about elasticity, and whenever I'm editing an object, it's right there. It's also a lot lower overhead. Rather than paying, for instance, a pointer for each of mass, friction, and elasticity, I pay one pointer for all three. On the other hand, you've got a couple of problems. Let's suppose, I have this object, and I have a basketball with some physics, and I want to make a friction-free basketball. But I want it to otherwise behave exactly the same as the normal basketball. I can't just, if I don't have subcomponent inheritance, I have to override the entire physics model or not at all. Right? I'd like to say, I want all the values there, except I want to change friction to 0. It's also a heavyweight allocation. If I have a totally static object in the world, it doesn't move, doesn't really need much physics, or any physics, but I want to give it elasticity properties so that I know how much things bounce when they hit it, I again have to add the entire thing. So there's lower overhead on tracking, but I may have to add more than I wanted to sometimes. So an example of a situation where things were broken up too much is the Deus Ex 2 inventory system. There's a few more components here, but there's 4 that are kind of important here. There's the inventory type. Is this a weapon? Is this a kit? What is it? There's the animations associated with using that. Those are both essential. Right? It won't function in inventory if I don't have those. And then very important but not essential are, what icon does it show? And what sound effects are associated with equipping it, unequipping it, using it, whatever. Now we could get around, as it turns out, designers are having some cases where we have to remember, I add the inventory type, I add the user arm animation set. If I forget either one, the thing is totally useless, and there's no point in having done it in the first place. Now we could get around this problem with having components require other components, so that I can't add inventory type without also adding animation set, or vice versa. But we don't have it. So in our case, these really are too simple. You can also get inventory components that are too complex. Dungeon Siege's inventory system for Dungeon Siege 1 their one component had 9,000 associated lines of code. It had tendency to have everything but the kitchen sink. And it's not all of it was necessary. Some of it involved how to animate armor on guys, and that should have been under the animation system. In fact, to quote Scott Bylas, he said, in the entire system, the inventory component is the worst thing. Okay, so that's simple versus complex components. Okay, when I was describing the problem on the inventory system for Deus Ex 2, I said, well, we could have gotten around some of the cases if only one component required another component, and they could forcefully add them both. And or another example is that there's no point in having a component that says how much to scale up the visible rendering of an object if I don't know how to render it in the first place. So we'd like to have some components require other components, either in a you can't add me without him already being there, or you add me and he automatically comes along. Deus Ex 2, in fact, does not have a system for this, and we're forced to rely on warnings, rely on setting default values explicitly, and all this adds to the time from when a designer tries to do something to when it all actually works. On the flip side, we might want to have components exclude other components. when I was talking about one of the benefits of object-centric systems versus component-centric systems is that I can scope components. And that the only way to do scoping of components in component-centric systems is to say, well, if you add this component, I can't add this one. For a more concrete example, I don't need a component saying what my mesh is for rendering and a component saying what my sprite is for rendering, because I'm only going to render as one or the other. And in fact, if I have both, it's very confusing without having a third one that says which one I use. If we could make them mutually exclusive and say, hey, I can't add the render mesh if I have the render sprite, or vice versa, I'd be a lot better off. And we might not want them mutually exclusive, maybe only need excluding one or the other. Some of you may be worried that this is going to cause a lot of extra logic when I'm changing values. Well, as it turns out, in a typical frame, we may have 5,000 queries, about 2,000 base queries, 5,000 total, 2,000 queries where I say what value is on this instance. So 2,000 queries in one frame and under 10 explicit sets, right? So set is it's an operation where you can really afford some more logic, especially if it improves our behaviors and queries later. It looks like we've done a lot, but this last topic is deceptively small on this outline. We talked about inheritance and a lot of the problems. One of the problems is that it can be really slow. So we want to talk about optimization strategies, which are caching, instantiation, and tree flattening. Dynamic archetypes. I mean two things here. Both changing the value on an archetype. So I have a medbot in the world, and I say, I'm going to make all medbots now have 30 hit points base. Or changing the archetypes for an instance and say, you no longer have that parent, you have a different parent. I'm going to talk about multiple inheritance. I'm going to talk about inheritance blocking. So caching. As I said, I'm asking for health on this bar stool, and it doesn't have it, and its parent doesn't have it, and its parent doesn't have it, and I do 6 lookups. Right? Total failures are really, really expensive. And even partial failures, where I ask an object and it goes up 3 levels and goes to the top before finally getting a value. Right? It's success, but it's an expensive success. We'd like to try to cache these where necessary. And the important point is, not only do I want to cache successes, but I really, really want to cache failures, because failures are typically much more expensive than successes. Good statistics can also inform what you want to cache. You may have flags that say, hey, look, I want to cache this, I don't want to cache that. It's not that important to cache hack strength, right? Sure, most of the object is not on, and if I query, do you have hack strength, it's going to say no and fail all the way. But I only query when the player, try to use a tool on that object. Right? That's a totally player-driven event. Never happens very often. It's okay for it to be relatively expensive as a query, because it just doesn't happen. On the other hand, if I want to know whether an object has physics, that really needs to be fast. Especially, I'm asking objects all the time whether or not they have physics. It'd be great if that kind of thing was cached, especially when it failed. Well, of course, whenever you talk about caching, you have to worry about cache invalidation. Well, the question here is actually, does it even matter? If you don't support changing the results of uptree queries, right? If I'm generally only caching when I'm running the game, so I'm generally concerned with instances. If I don't care about changing the results of my, what values are on my archetypes or what my archetypes are, the kind of dynamic archetype things, then I can't really invalidate my cache. And in a lot of systems, these things aren't supported. And it's really not a problem. And caching is just a simple thing to do that really gets you a win. I mean, you just have to track how much memory to spend on caching, but it's a fairly simple problem. In those cases where you do have dynamic archetypes and you do have to worry about cache invalidation, that's more of a programming problem where there's a lot of literature already on the subject, and I'm going to leave it to you to solve the cache invalidation problems for you. Another thing that's kind of like caching, but it's not on the fly, it's kind of an explicit thing, is instantiation. And the idea here is that most of the time we're querying about instances, and they're the ones where failures and successes are important. So whenever I create an instance, I'm going to, for every component that's marked as mattering for instantiation, I'm going to do a query and say, hey, does any of my parents have a value for this? Right? So I place the bar stool and I say, do any of my components have a value for the health component? And the answer in this case will be no, so I don't put it on. And that doesn't seem useful in itself, except that because I've said every time I have a value, I'm going to put a copy on me, it's implied that if I don't have that value, there is no point in going up the tree, because if I had a value up there, I would have done it. So when I check the bar stool and say, how much health do you have? It says, I don't have it. And I say, okay, it must not be up there because it would have been on you if it was up there on the archetypes when you were created. It's often fairly useful anyway for things where instances are likely to differ from archetypes anyway. Right? It is a memory cost because now I'm putting these values here. But if any time I was going to care about it, the instance would differ, like perhaps when was the last time I was rendered, I don't pay much memory cost at all, and I still get all the benefits of caching out failures. You do have the same potential for cache invalidation. If my archetypes can change, because I've got dynamic archetypes, I have to worry about that. So one of the things is you can do this as part of the editor. Like whenever I create an object, copy everything down. But if you support that in the editor, well, the editor is the time when archetypes do change, even if you aren't supporting dynamic archetypes in the game. It's very easy to get cache invalidation problems with instantiation there. We do it, for instance, as a step at when I start running the game, it sets this information up so that the queries in the game are fast, but I don't have any problems with invalidation through the editor. For what can kind of go wrong with the editor, well, Thief 1, they did instantiation in editor on object creation, and they had their physics component. And the physics would occasionally change for objects. And so everyone has to do kind of a global find and replace all the physics values for everything that descended from that archetype. But sometimes you wanted to, you explicitly had wanted to override that. There was a designer who had a key hanging on a wall. And we didn't actually support, having the key fit on a peg or anything, so he just put the key in the right place and turned it off physically. I mean, it would all work when you picked it up in the game and dropped it, it would behave that way. But right then, it was supposed to be non-physical. And every time we ended up having to fix physics, it would end up on the floor. Now, keys didn't happen that often, but it happened a couple of times, and there were certainly other cases where this caused problems. A couple of statistics for querying for Deus Ex 2 for instantiation and inheritance. This is just a frame on a level, and we did 2,400 queries. We said, what's the value on you? It turned out about half of them were for components we had marked as instantiated. About half of them were for components we had marked as inherited. And about half the instantiated queries failed. So every time one of those failed, we would have spent about 5 levels going up the tree because it would have been a total failure. So that's clearly saving us some. Inheritance, we've kind of marked things sort of appropriately the right way. For inheritance, if I had to go up the tree, I didn't have to go up all the way. But it's important also to note that some things really need to get fixed. Like, here we have an example of what's going wrong. Physics is inherited, and it should be instantiated. We do 160 queries in a frame, and we end up doing 819 lookups because we're going up the tree a lot. Mesh is, on the other hand, working perfectly. We do 637 queries, and we do 637 lookups, right? That's a quarter of our queries. If every one of those was failing all the time and going over, that would dramatically increase the number of lookups we're doing over a frame. It's not always necessary to instantiate. The pre-pivot component, sure, it fails some, but it doesn't go up that far when it does. So it's really not buying us much to instantiate it everywhere. Okay, the last kind of inheritance optimization is tree flattening. You can kind of think of this as instantiation, but for the level above instances. It's for all archetypes. Basically, what I do is as a step, when I'm about to go into the game and I'm not worrying about editable data, I say, okay, you the barstool archetype or you the medbot archetype, find all the components above you and their values and copy them onto you. And of course, this increases your memory footprint because now you are storing redundant data everywhere. But you don't care, but the redundant is only a memory problem because you're not editing things anymore. Dungeon Siege does this technique. And of course, this really causes cache invalidation problems. And the other is you may have to fix some data. Here, your archetypes have lost their inheritance, and they really lost where the data came from. So that's a lot of caching strategies. And we talked about how you don't generally have to worry about cache invalidation unless you support dynamic archetypes. Well, why might you support dynamic archetypes? Well, the first type of dynamic archetype is where I change the value on an archetype. I say, all medbots, they're now 30 hit points instead of 25. For single-player games, I haven't been able to find a good, convincing argument for why you'd ever do this. Except that there, what I think I do is I would just upgrade all the existing instances, and then I would mark it so that I no longer spawn the old soldier. I spawn the new soldier type. I would just delete all the existing soldiers and create new ones, potentially. Like, there are other ways to do these. And it's a huge, you have to deal with so many other problems by supporting this. On the other hand, if I have a massively multiplayer persistent world, what about then? Right? Everybody's got, all these players have been trying to get this demon sword +4. And they, for game balance purposes, they all have to behave exactly the same way. And then I want to do a patch. And we say, wow, it's too weak or it's too powerful. We need to tweak its values a little bit. Well, a really simple thing would be to say, okay, we're just going to tweak the value in the archetype, and it'll automatically update all of them, right? We don't want to shut down our servers. It just needs to automatically work. And so in massively multiplayer games, it seems like there are good uses for doing this sort of thing. Star Wars Galaxies supports some of this, for instance. Okay, what about if I want to change what I inherit from? Right, I want to change which archetype is my parent. Again, I can see some uses, but none of them seem worth it in your typical single inheritance, single player system. You just copy the relevant data over to a new instance, delete the old one, create a new one, copy whatever changes you need. But maybe it's worth thinking about. However, there are use cases under a multiple inheritance model, right? They've actually been used in Thief 1. So it's shipped, it works. So multiple inheritance. Well, first we're talking about inheritance of data, not code. Right? If you start doing multiple inheritance in code and overriding functions, you're going to really confuse designers who are trying to work with this. They can't see the stuff underneath. It's going to be confusing to them. So the key is it needs to be very, very simple and clear. There need to be explicit rules for when I do a query, which parent do I ask first? How do I go up that tree? And obviously, that needs to be explicit designers in the editor, right? I need to see, okay, here's the values on this. I understand why I get these values because these are my parents. And this was used in Thief 1 for their meta property system. So meta properties they're just archetypes with data associated with component settings. They're just kind of like any other object. They've got some data assigned and designers set them up. There were generally about two types. A lot of them were vulnerabilities. Like I have the wood vulnerability. It says sword does quarter damage, fire does full damage, poison gas attacks do no damage. It's got all these settings. And I can't, I may have wood objects inheriting from different places. I may have wood under furniture and wood under kind of set dressing stuff and maybe under doors. And they can't really, but I may have metal doors too and metal furniture. They can't easily inherit from the same thing. But I want to make sure the data is not redundant. I don't have to duplicate the data everywhere and worry about it being in sync. So they would have multiple inheritance. And all of these objects would, in addition to inheriting from the normal archetype, would inherit from the vulnerability. And they were very simple. They didn't override very many things, and they were used for only a couple common purposes. They were also used to affect NPC behaviors. When a guard was sitting down, right, he wants to play different animations. He wants to have different response to alertness. He wants to seed a little bit differently. And so you don't want to have code explicitly set these or write some complicated script explicitly and remember, oh, I have to go change that script to set these things. Instead, what they have is when the guard is sitting down, he has this meta property on him that says what things it overrides. So he plays different animations, he plays only the sitting ones, he may say different things, and he sees differently. And then when he stands up, we just remove the meta property, and he reverts to normal guard behavior. And this way, designers can say, here is how a sitting guard behaves, and it's easy to do and in data and easy to find. Of course, in this case, when the guard stands up, you're changing the meta property, but that's in-game, right? So now you have all these caching problems. You have to worry about the results of upstream queries changing, and you're going to have to worry about cache invalidation. In fact, Marc, when he did the Thief1 system, had this complicated system of dealing with that. And I'm glad I don't have to write one. But it is an easy way for designers to control behavior, and it can be worth it to help things be data-driven. Finally, inheritance blocking. Let's suppose a parent archetype has a component like a damage model, but this archetype doesn't want it because it's invulnerable or whatever. But I want all the other settings of the parent. If I try to move this elsewhere in the tree, I now have to duplicate and make redundant copies of all the data that my parent used to have. And again, you have the synchronization problem. What it'd be nice if I could maybe say, I really don't want this one component, but want everything else you've got. You can kind of get around this. I mean, we don't, unfortunately, support the system. And because we don't have that many cases where we want it, and the few cases where we want it, we're kind of forced to resort to having default values or specific magic values. Say, okay, I have a damage model, but I'm going to mark it so that it basically doesn't count. And of course, that's more memory, and we like cleaner ways of doing this sort of thing. That's basically the information in the talk. There's a lot, unfortunately, there's a lot more to these kinds of things that I didn't have time to get to. I just want to go over these things again. So static hierarchies versus dynamic hierarchies. Dynamic or component-based hierarchies, they provide flexibility for future design decisions. I don't get locked into a design decision I made now that will turn out to be wrong later. On the other hand, static hierarchies provide a lot of speed. Component-centric versus object-centric. Well, component-centric systems provide a lot of efficiency when you're managing the existing object pool, because components can manage how they align their data, what access patterns work. On the other hand, object-centric systems are very easy to write, they're intuitive, and they make it a lot easier to add and remove objects in toto. Simple components versus complex components. Well, simple components support inheritance a lot more easily, right? I don't want to override the 10 digits of hit points. I want to take the entire thing or only some of it. On the other hand, there's a lot of extra overhead spent in tracking. There may be additional necessity for intercomponent dependencies, more memory fragmentation perhaps. And complex components encapsulate entire concepts better. But if I want to do inheritance properly, I have to do subcomponent inheritance. Inheritance prevents duplication of data for designers. It saves some memory. It makes it easy to keep data in sync. It can be potentially slow. Failures are particularly expensive. And there are optimization tricks, but they also make it harder to do other things like dynamic archetypes. But for many people in single-player games, dynamic archetypes is not going to be a necessity. For instance, for us, we don't do the AI behavior thing. And for vulnerabilities, we have a special system that allows us to get alternate inheritance from another area so that we can not have the redundant data problem. A quick reminder of what I didn't talk about. Except for a little bit in dynamic archetypes, I really don't have much experience in massively multivariate games. I didn't talk about them much. I didn't talk about networking much, how to communicate value changes across the network. You can make one of these systems work that way. System Shock 2 was networked using the Thief1 object system. And I don't talk about the effects of the system on end users trying to build content. How does this make it easy for mod developers, for level builders? And a big thing I didn't talk about is how you do references between objects. There's a lot to talk about there, and I just didn't have time. I want to thank a few people for providing me with information about their systems. I want to thank Scott Bylas for information about the Dungeon Siege system, Chris Butcher for information about Halo, and Steve Jakob for information on Star Wars Galaxies. And for a bunch of people who helped me with the information about the Thief 1 system, Doug Church, Randy Smith, and Chris Carollo. So now we've got some time for Q&A. I just remind everyone to fill out your evaluations. I may not have time to answer your question right now, but I'll be around to talk some afterwards. And after GDC, not tomorrow or tonight, but sometime next week, you can find the slides at the specified address, and you can email me there. So, questions? Yes? So the question is, what kind of debugging tools are available for this? And I just want to ask, do you mean debugging tools for designers looking at their data or for programmers looking at the code? Okay. Well, first, the idea is, in C, he says you can see the member variables. For a programmer who's concerned with how the object is not behaving properly, can go into the editor and see the data and check the data. It's helpful often to have runtime availability to look and set changes. Now that can break caching, obviously, if you can change data on archetypes. But you can turn off caching for that. I mean, it'll affect performance some, and doesn't help you debug caching itself, but can allow you to make changes there. And a lot of it is just, making sure, having code that's guards well against checking. Do I have the right data? Do I have the right data? Do I have the right data? Yeah.
Yes, I got a little confused with archetype. I mean, you have objects which are really just identifiers that are in component tables. And is an archetype a parent object? Is it a parent to the components?
You mean, okay, so the question is, so the question is, in a component-centric system, what is an archetype? In a component-centric system, an archetype is just an ID that if this component says, what is the value I have associated with ID 5, and doesn't have it, it can go to the parent component and say, what is the parent of ID 5? What is that ID? And then I get ID 3 back, and I go back to my component and say, what is the value I have with ID 3? Yes, in the slide, the parent component was how it defines what the archetype is. Yes?
Is there ever a time when there's a data that's required for one component that might be required for another component, like maybe a position in a rendering component and a position in a physics component? Is there one time when the data needs to be duplicated because two different components need that same type of data?
So the question is, let's suppose I want to consider position. I might want that in my rendering component. I might want that in my physics component. I think that's a case somewhat of components being too complex. I would say you may want a location component which specifies, here's the location of the object, here is its orientation, maybe here's its velocity, although that may end up wanting to be in the physics component. And just making sure you put things in the appropriate components. Yeah?
C# doesn't allow multiple inheritance. And I was just wondering if you could talk about the trade-offs of that or ways to do the same thing with single inheritance.
So the question is, C# doesn't allow multiple inheritance. And how can you do this? What can you do when you only have single inheritance? Well, the important thing is that multiple inheritance in this case is a data-only thing. I don't write C code that says, I'm actually going to do multiple inheritance from that, because I think that will be confusing to designers. It's purely a data thing, which should be language independent. Yeah?
When you reference these different nodes on this object, how
So the question is, if I want to find a particular archetype, do I have a full path which says, okay, this is the actor AI medbot, and I find it by like searching directories, or do I have a specific maybe pointer or reference to that object? I haven't really thought about why you might do the pathing thing. We do it as explicit references. And there is a lookup table where we can say, okay, I know the name of this thing. Can you give me a pointer to it? And if I need to maintain references between objects, we have a system, a link system, where the links will delete themselves if either end goes away. And I don't know why would I use. I have not yet seen an application for referencing my path.
How do you differentiate in data and in code between an archetype and an instance?
Okay.
You mentioned that there's some components are inherited, others are instantiated. Is that an example of one and only difference?
So the question is, how do I differentiate in code between archetypes and instances? And one example is some components are instantiated, they get put on instances, and some are not. Is that the only example? I think it's important for code to know about the difference because, for instance, when I'm saving my game state, especially if I do not support dynamic archetypes, I don't need to save any of the archetypical data. I only need to save the instances. And generally that's tracked by, I have to make sure the instances are part of whatever level I'm in. And I think code will generally have to know that this is the instance anyway.
Is it just a flag, or is it actually a different class environment?
For us, it's actually, like on our system, which is a modification of Epics, it's actually a different class entirely. For a component-centric system like Thieves, it's just an ID. And there's a flag, there'll be I guess a component that says whether or not this is an instance or not. Actually, scratch it. On Thief, negative IDs were archetypes, and positive IDs were instances. And so there was an implicit flag built into the ID. Yeah.
How do you go about storing and managing converting between different types? For example, property would have to be either like a three-component vector or would just have to be a string. How do you go about storing these, converting these?
The question is, how do I do a general storage system for, kind of to be able to say about vectors and strings? That's kind of up to you. We both have a binary representation where we have to have special loading code to deal with it, and a sort of slightly more editable and easier to track change-wise text representation, which just says this component has this value and it's all printed out into strings. Yeah.
Since the proposed system hierarchy is a purely data thing, there must be some interpreter, some kernel that imposes a performance penalty compared to hand-coded C++ code. So, did you make any estimates of that penalty?
So the question is, because the hierarchy is not compiled in and the data is not compiled in, I have to have code to find out what my parent is and what data I have on me. And have I made estimates about the penalty? Yes and no. We know how many milliseconds it takes to do a lookup. It doesn't actually take in milliseconds or be screwed with 2,400 lookups this frame, but we know how much time it takes to do a lookup and how much time it takes to load. And for our purposes, we basically assumed that if it were a member variable, it would be free. I know virtual functions aren't quite free, but for just straight up member variables, we've just said, okay, every time we spend is additional, but it's worth it for us in terms of the inheritance savings. And I think it's very important that this is a system you do have to profile. Like, you have to know, should I mark this instantiated? What do I want to do about caching this thing? Or even get designers to say, hey, look, you really should maybe rearrange your tree a little bit to fix these problems, and that can be a big pain. It's nice to have other methods to speed things up first.
You did make any comparisons, like implemented one, the same system, the same, say, experimental game as a traditional C++ code and as your object system and compare the performance?
I mean, as I said, we did not do performance comparisons, except that basically my assumption is that any time I spend in our system is time that the other one would not spend, and those are effectively free. So if we spend 1 millisecond a frame total on queries, and that's the cost of our system.
And if I want it much, and suppose I'm willing to write an automated compiler, is it possible at all to compile your database hierarchy into solid C++ code?
Yes, you could. The question is, can you write a compiler that would compile this database into actual C++ code? And yes, you could. The problem is, after you do, now I've kind of violated the thing of not wanting to recompile when I change data. And if you do it late in the project, after you've kind of got a good estimate of how everything works, it would solve a lot of the data changing problems. But now I've just changed everything right near the end of the project, which causes potentially a lot of other issues with test and everything. Maybe. Yeah.
I was wondering where you actually do in your system, do you the inheritance mechanism of the language? Yeah, I got confused when you talk about inheritance, and I wasn't sure if you're talking about kind of archetypal inheritance or the language's actual standards like C++ inheritance. You use it in components, I guess, right?
So the question is, where do I use any actual C++ inheritance? Well, for a couple of things, like as I said, for us, we're a kind of static dynamic hybrid. I don't think a truly dynamic one uses anything. We have, our particle emitters, all the code relative to doing updates is just on them. In fact, it's not even a dynamic component. We know every emitter wants this information. There's no need to, we want it to be really fast. There's no need to change things. And if we want to add a new thing, we do it. And it's a fairly small set and a fairly flat tree. Yeah.
Is your table stored just in some kind of file that maintains parent-child relationships on each tuple? Because there's lots of approaches to storing a hierarchy in kind of a flat system. Did you find one way that gave you the best performance for facilitating these queries, these multiple queries you had?
The question is, how do we store data to facilitate queries? Well, as far as queries go, we load everything into memory that we need, that we're going to need during the entire game. I mean, not necessarily textures, but all the values, like what texture I'm going to have. The way we store it is we just have each object has a hash table, or pointed to a hash table. And that hash table has, it keys on an ID for each component, and it has some value. When you do a query, we copy that value over, so you only get copies, so that you can't, we just try to protect our abstraction.
Is it tabular, though, with the parent-child relationship to maintain the hierarchical structure?
If I don't have it in my hash table, I ask my parent, and he does his hash table. I have a pointer to my parent.
Did you mention some resources for the thing you didn't talk about, the inter-object reference?
The question is, are the resources for the inter-object references? I took my system for those basically straight from Marc LeBlanc's system on Thief. I don't know what he's done to talk about them. The talk this morning by Tom Leonard about the AI system kind of mentioned some of that. The AI has used these references. And I mean, for us, we just had references that have data hanging off them for various features. But I don't know. I mean, the short answer is I don't know a good place to send you to a reference.
I was curious how much, like the conflict issue between components, I saw you set some up to be mutually exclusive, but two related questions are like, any thoughts on how you deal with conflicts and how much dependency is there between, the components? One of the factions of this is that, you could add components without changing the other components, and I'm wondering in practice, is that really possible?
So the question is how much, I've given some examples of components having weird interactions. How much does that actually happen? When it happens, it's generally because we've done something wrong as designers, like splitting up the inventory too much. Okay, well that's the one case. The other case for the render scale mesh. So the question, right? The question is, if you actually have two components and they're incompatible, what do you do? Mostly, you first try not to write components that way. If you do write components that way, for instance, in the render mesh render sprite example, there you could add another component which says, okay, which one am I going to use? Or you merge it all into one render component which says, here is my mesh and my sprite, I don't have anything. I mean, part of the example, the larger your components, there are penalties to that, but the simpler your intercomponent interactions. The real trick is just making sure your components are the right size, small enough or big enough, and there's not an easy answer to that.
Where did you put the cache data?
The question is, where did I get the cache data? When I wrote the system, I immediately put in tools for tracking it, so we knew which things we wanted the Marc instantiated later. And I just ran a level and output a frame's worth, and then took properties that were good examples.
If you're object-centric, where did you put your cache data?
We are object-centric. I just say whenever I do a lookup query, I mark that down. I mean,
for example, the physics component is in a parent, but
right.
you query a child.
Right. So, okay. Where would I put the cache data if I were caching? Is the question. Oh, okay. I might mark on the child. Look, there might be a separate. I mean, it depends on your implementation. Maybe I just have a separate thing that says, hey, if I ask me for this, I don't have it. Or if you ask me for this, go here and ask directly. I mean, it's another database. It's kind of a database problem specific to how you do it. And we have not written a caching system for our system because we do not support dynamic archetypes. So we're relying on doing instantiation as our main method of caching and pushing data appropriately where I need it to speed things up, and a lot of statistics.
I was just wondering, I know you didn't cover inter-object referencing, but what are some of the issues there that you found you had to address, just things to think about?
So the question is, I didn't cover object references, but what might be issues? Well, I mean, one, you want to make sure that I don't get stale references around. It's kind of the obvious one. The second is, do I want to have data on them? One type of reference we have is a Flinder link. And the idea is, if an object is destroyed, it finds all the Flinder links it has and creates instances of those archetypes. And the link says how many to create, what velocity to give them, maybe what random application for that, so that because the designer cares about the reference, he wants to see the data for the reference right there.
You must have code somewhere that deals with these properties, like the hack value, how strong something is. So there must be some communication between the code and the designer, or is that
There's the question, is there interaction between the code and the designer? And absolutely, right? I mean, one of the clients of the object system include programmers, right? Our inventory system has to be able to say, okay, what is my animation? And now I'm playing the equip animation. Can you give me my sound effect to play? It does a query, and it gets back a copy of the data, right? I mean, it has to be available to programmers, or it doesn't really do a lot of good. If it's just data that sits there, at some point, you have to have an interface between the data and the code.
So the linkage is pretty weak, and you could potentially query it on a product that doesn't have it.
Absolutely. You can query. The question is, the linkage is kind of weak. You can query an object for a property it doesn't have. And yes, you can. And you have to be able to deal with that, which is, I mean, a lot of times that's what I do. Like, I try to use this tool, this multi-tool on this keypad, or not on a keypad because it would have it, some object on the player, and our code says, tell me if I have a hash strength. And if I don't, I disallow the interaction. Right? I'm using in that case, use the fact that you don't have a component as a value.
How do you deal with questions with like type identity in, I guess, the component-centric system, or if you have inheritance blocking? Like, is this a var string?
Okay, so the question is, how do you deal with type identity? Well, if I want to know if this object is another object, first,
I guess not necessarily if it's a particular var stool, but whether it...
no, I want to know if this object is this archetype. I need to get a pointer to that archetype. Maybe I go through the name table. This is in a component-centric system. Maybe I go through the name table, find where that name is, what the ID is, and then I go to the archetype table and start looking up IDs and tracing them to see if I ever get there or if I get to the base.
So, or I guess since you're not doing inheritance blocking, it's probably not come up, but how, is there any decent way of dealing with something that might be a var stool, but it's an invincible var stool? Maybe that screws you up.
So the question is, we're not doing inheritance blocking, but how might you do inheritance blocking in a component-centric system? Basically, inheritance blocking in that case would be a cheaper way. You still have to store some data for the component to say, here's the things where I've got blocks. So when you ask me, I don't do it anymore. I mean, we haven't written it, so the implementation might differ for you. And we did not write a component-centric system, sometimes much to my chagrin. So I can't tell you exactly how I would write that code without writing the code. Oh, there you are.
One of your goals, as you recall, was save memory.
It's not just to save, the question is, one of my goals is to save memory. How much should I save? Well, the thing is not just to save memory. It's that in a static system, changes later are often very expensive because I can't just push data up. In some ways, it costs more memory, right? I have to store information about whether or not I have the object, which is additional memory. It really depends on your game whether it's particularly going to save you or not. The main goal is not to save memory. It's to make sure that designers can have the flexibility they need without ballooning your memory cost and pushing everything up. Like, it saves memory over the super flexible original system, but it won't save memory at all over a really well laid out hierarchy. Okay, I'm told I have to stop.